Okay, this is the third vodcast on bonding, and this vodcast covers covalent bonding for Unit 4. Okay, so bonds are forces that hold groups of atoms together and helps them function as a unit. And so we've already discussed ionic bonding, which is where there is a transfer of electrons. They can either be gained or lost. And then this section covers covalent bonding, which involves the sharing of electrons. And when they share electrons, the resulting particle is called a molecule. So many elements in nature take the form of a molecule. And the definition of a molecule is a neutral group of atoms joined together by covalent bonds. Again, there's that idea of neutrality where the positives and the negatives cancel out. So if we take a look at air, air has oxygen molecules consisting of two oxygen atoms joined covalently. It also has nitrogen molecules, which are two nitrogen atoms joined covalently, or carbon dioxide, CO2, where it's got a carbon and two oxygens also joined covalently. So if we take a look at the simplest example, which is H2, our hydrogen molecule, what happens is you've got these positively charged nuclei, and they're going to repel each other because of that positive charge. But if you bring in electrons, they will help bridge that gap there, and they're going to share electrons for the same exact reason ionic compounds do. Transfer them. It's to complete an octet. Now, the important thing to note, because it's there in all caps, is that covalent bonds are only with nonmetals and other nonmetals. So just concerning those small group on the right-hand side of your periodic table with the addition of hydrogen. Hydrogen, if you recall, is also a nonmetal. That's why I have this example here. So nonmetals don't transfer their valence electrons, they get to keep them. And so they have to find another way to bond. Well, they do this via sharing in order to get that noble gas configuration. So when the valence electrons are shared, you get covalent bondings. When this happens, both atoms get to count the electrons towards a noble gas configuration. So it's like some electrons get counted twice towards noble gas configuration. So it's a nice way of double counting things in order to get that 8 that they're looking for. So if we take a look at fluorine here, fluorine has 7 valence electrons. If I take a second fluorine, all right, it still has 7 valence electrons. But fluorine wants 8 valence electrons. It wants to have a noble gas configuration. So what they decide to do is they decide to share electrons. And if you watch here in the picture, they're going to start to come closer together. Okay, now fluorine and fluorine are side by side, and they both have full orbitals. So this fluorine on the right has 8 valence electrons. Here's 2, 4, 6, and then 8 valence electrons. And then on the left, this fluorine also has 8 valence electrons. 2, 4, 6, and then 8. These electrons get to be counted twice. So the one fluorine had 1 valence electron there, the other one had another valence electron in the same region, and so they got to share those two in the middle. Now those two being shared in the middle are called a single bond, okay? And so when they get shared, that's the actual bond. So 2 shared electrons make a single bond. We've got other types of covalent bonds in addition to single bonds. We have double bonds and triple bonds. So a single bond is 2 electrons being shared, and it's a single line. A double bond is 4 electrons being shared, and it has a double line. Triple bond, 6 electrons being shared, and it has 3 lines, like that. Each line is 2 electrons. Okay. Now, electrons that are not part of a bond are called unshared pairs or lone pairs. So in that fluorine here, okay, we had that bond. Here's that fluorine we had on the last slide. And if we're trying to look for unshared pairs, here's 1, 2, 3, 4, 5, and then 6. So this fluorine had 6 lone pairs or 6 unshared pairs of electrons. So when we have compounds bonded covalently, they're called molecular compounds or molecules. For their properties, molecular compounds actually have lower melting and boiling points than ionic compounds. So you should be able to tell the difference between a molecular compound and an ionic compound based on the boiling point, high boiling point or low boiling point. If you recall in the last one, salt melted at about 800 degrees Celsius. That's just melting, okay? Ice melts at 0 degrees Celsius and boils at 100 degrees Celsius. So its boiling point is, still even much lower than NaCl, an ionic compound. So consequently, because they have lower boiling points and melting points, most of your molecular compounds, not all of them, tend to be gases or liquids at room temperature. Okay, if you think about it, we've got water, H2O. We've got carbon dioxide. Oops, that's not the formula. Carbon dioxide, like that, CO2. That's also a gas at room temperature. Now, not all of them are gases at room temperature. You also have sugar, C6H12O6, and it's a solid at room temperature, but you can also melt sugar in the kitchen on the stove, and that's what we do when we're making candy. You'll also ruin a pot that way if you're trying to just melt sugar without any additional ingredients, but it is possible, unlike salt. So, molecular compounds generally are gases and liquids at room temperatures, whereas ionic compounds are pretty much always solids at room temperature. So a molecular compound consists of a molecular formula. It shows how many atoms of each element a molecule contains. This is similar to a formula unit, which also did the same. So if we take the example of water, H2O, the subscript behind the H, the subscript 2 behind the H means that we have 2 atoms of hydrogen. So 2 hydrogens. And if we only have 1 atom, we omit the 1. Okay, chemists are fond of invisible ones. So we actually only have 1 oxygen in that formula. You would never write it as H2O1 like that. That would be incorrect. Now, the thing about molecular formulas is they don't tell you about the structure of the atom or how the atoms are arranged, how they're bonded to one another. They just give you the formula. They tell you how many there are and what types. You guys are actually going to do a lab with the molecule kits where you'll get to play with the structure and kind of figure some of those out on your own using molecule kits. So here now we've kind of finished off this section with covalent bonds and then Lewis dot structures. How do you construct Lewis structures for atoms and molecular compounds? I just gave you the briefest introduction on making a Lewis structure for a molecular compound. That's what I did with the F.F like that, or F-F. That was a Lewis structure for a molecular compound. I actually have a whole separate vodcast on constructing Lewis structures that you should watch next in preparation for your lab.